Hi everyone, this is our next geography assignment. You do have almost 2 weeks to complete this because there are a number of tasks. This week we're going on another virtual field trip as part of the assignment, and we're going to develop a number of skills that are really important in the advanced hydrography course, but actually also important in conducting your own field research. So what you learn in this fortnight's work will help you with your project. Right, we are going to be doing a pebble analysis. That's the actual type of geography study that we are conducting. And it's linked to, if we go into our virtual textbook, the section that starts on page 15 on, just scrolling up again, on conducting a pebble analysis, looking at the size, shape, and rock type. So this is a skill area in geography that you have to be familiar with. And sorry, I said page 15, page 16. And the skills you're going to develop in pebble analysis involve why would you gather pebble data? You have done this before in higher when you gather pebbles on a river. But in this example and in this lesson, we're not going to be looking at rivers, we're going to look at beaches. And what pebbles are great at doing is they show us how the forces in nature sort and organize material by moving it. So glaciers move large amounts of material, so do rivers, so does the ocean, and they transport it. And then when they switch off, or in the case of a glacier, when it melts, or when a river runs out of energy, or when the wave runs out of energy, they deposit that material. And that leads to a huge range of different landscape features that exist in our landscape. Okay, so first thing you'll be asked to do is actually read a pebble analysis, and therefore I would go on to page 16. Also have a look at some of the data presentation techniques you can use to present data on pages 17 and 18 and 19. Specifically on page 19, there's a little bit on swim and rank test, and part of this lesson will include that. Okay, jumping back to the main bit of the lesson. So we're going to do a pebble analysis. Actually, what we're going to do is we are going to imagine we are at a beach and we are studying longshore drift. Okay, so if you just remember what longshore drift is basically about, it's the fact that waves come in to the coast at a slight angle, and that's to do with the prevailing wind pushing the waves in at an angle. And as they move up the beach in the swash, they move sediment, sand or pebbles, up that beach, and as they drag back because of gravity, they go back perpendicular to the beach, so directly down the beach, and pull that material back. And this effectively means that material, whether it's sand or pebbles, are moving or zigzagging along the coast over time. They're moving sideways along the coast. And what you're going to do is explore the effect that has on sorting material on a beach. And the main idea here is, or the main theory is, that with longshore drift, you would expect a way to be able to move smaller material like sand and small stones much easier than it can move bigger material like bigger stones or boulders. And because of that, if you're standing at one end of a beach that has longshore drift affecting it, the big material will stay in place, whereas the smaller material will start to move sideways and get sorted. So as you walk along a beach, and next time you're out walking on a pebble beach in Scotland, you will probably notice this. One end of the beach has got mainly all the big stuff, and as you move further along the beach, you start to find the sediment gets smaller. Or the way you could test this is start walking from one end of a beach, pick up a stone. It's got to be a pebble beach, obviously, and sort of every 20 meters, pick up another stone. Number each stone with a pen, so number 1, number 2, so you know which order you collected them in. And then when you get to the end of the beach, you could sit there with a ruler and measure each one. And what you'll probably find is the first one you picked up is either going to be the largest or the smallest. It depends which end of the beach you're starting at. And as you move further along, they'll either get larger from that point or smaller at that point. And that obviously depends on which direction longshore drift is moving. Now, obviously, one stone is not going to really prove or disprove that theory, but that's what we are looking at. So let's get on with the kind of key ideas in a pebble analysis. The first thing I'd like to do is watch this video. This is going to take you to New Zealand, and our presenter is going to talk through a whole range of coastal landscape features, specifically focusing in on coastal transport and deposition, longshore drift, and some other things, which is a really interesting program, and it's at a much higher level than anything you have ever done in geography to this point. And once you've done that, you're set up with some sort of key ideas to do step one, which is justify why you would do a study. Why would we and why should we investigate the size of stuff on a beach? Why are beaches important? Now, when you watch the video, they do start to talk to you about the importance of beaches and what they represent and how we can interfere with beaches, how human beings do all kinds of things like building groins, as an example, which affects the transportation of material along the coast. So you need a rationale, and every good introduction always includes 3 or 4 reasons for conducting a piece of research. When you have completed that, and you're also going to be citing, by the way, so if you go online to sort of type in, why would I conduct a beach study? Why would I measure? Why is it important to understand beaches or anything like that? If you take some information from a website, and I would strongly encourage that you actually do this, then can you give me a short web link underneath the text? And by I mean a short web link, not this. This is a long web link. The short web link would just be youtube.com. That would be the abbreviated version. And that's called citing. And you do that because you're getting your information from someone else. Right. You're then ready to start doing some background research. And in this is all good projects. When you have a theory, and the theory in this case is that you believe that longshore drift is causing pebbles on beaches to be sorted into different sizes, you have to back that up with evidence. So you need to go online and find a bit of evidence, maybe find a diagram, find something that proves the argument that larger stones are often found on one end of a beach and smaller ones as you move further along. I just want one piece of research that explains longshore drift, so I understand how it works. And then one bit of explanation for why we find larger stones on one side of the beach than the other. And I would like at least one citation for where you got your sources from. When you do a piece of background research in your real project, you're going to be inevitably doing a lot more than just one piece of research. Right. And now there's a little bit of reading. And this is more to do with establishing a theory and a research question. Once you've done your own research into the thing that you're interested in studying, you then have to formulate a hypothesis along with a research question. It basically means, what am I going to research and what do I believe I'm going to find? And it's not just what you believe because you've got a hunch or you've got some kind of vague idea. You always come up with what you believe based on the research that you've conducted, which in this case is normally something done online. So in this case, I'm going to give it to you that I believe that the average size of a pebble is going to get smaller in size as I move along a beach. Of course, that actually does depend which side of a beach you start on. So if you're starting at the far end of where longshore drift is happening and start walking backwards, you'd actually find the rock size would be getting bigger. But in this case, let's start with where the rocks are at the beginning of longshore drift and work our way in the same direction that the longshore drift is moving. Right, got a little bit more reading to do, and because now we're going to look at discussing locations. So this tutorial is got me telling you how to find a suitable map and find a suitable photograph of a beach, and you've got free choice of anywhere in Scotland to pick a beach. You're going to use Google Earth to find one. What's important is that you take a screenshot of that beach and that you describe where it is, where it's located. Now, I do in my second tutorial, this one here, I do actually tell you how to describe locations in a bit more detail. So you might want to watch that too, or certainly the first couple of minutes, I spend a bit of time talking about how would you actually write a description of a location of a study area. Right, what you then got to do is find actually a photo of your beach. Now, problem with beaches is cars don't tend to drive up beaches, so you might find you can't use the street view in Google Earth. There's this website, and I show you in the tutorial up here how to use it, which is going to probably help you find a photograph that somebody's taken of your beach. Okay, because it's got tens of thousands of photographs attached to every location in the UK. So I'd be surprised if you can't find a photo. And then I want you to annotate that photo with a whole range of reasons for why your beach is at a suitable location for you conducting this research. Okay. And that's all explained in the tutorial for, what are the reasons we would, or what would make it a good location for a piece of research. Okay, you then got to watch that tutorial if you haven't done so already, and then start talking about sampling. Now, you did this last week, and this is where you need to use Digimaps to extract an ordnance survey map. I want you to then use the Google Draw tool to draw the line which you would walk on. I want you to be very specific with this line that you're going to add to your map, because it must be the same distance from the shoreline. If you zigzagged up and down the beach towards the sea and back again, you'd be gathering inconsistent data. So, for example, if the tide was at a certain point, you would always want to be sort of maybe 30 meters away from it, or 10 meters, or 20. It doesn't matter, but as long as you're consistent. What you've also got to do is add 10 locations, 10 dots to that map where you are going to actually physically stop and gather your samples. What I'd then like you to do is read this, and using the tutorial that above, you then have to explain a sampling strategy and justify it. You also have to do this bit where you have to tell me how many pebbles you're going to get at each location, and you have to tell me the method that you're going to use to actually select those pebbles. Now, that's all described in that tutorial, but when you get samples, but you obviously can't gather thousands of pebbles at any given time, you have to decide, how are you going to pick them up. And by the way, bending over and just picking up a rock isn't a valid method of gathering a sample. It would be a highly biased piece of data. And I talk about that in my tutorial. Right, that's us getting to the end of the lesson almost. We've now got the main bit of analysis. I'm only going to ask you to do one bit of analysis this week, and this is using a statistical technique to test whether there is a relationship between where you are on the beach and the size of rocks. And it's the idea that as you move further along the beach, in this case, following the direction of longshore drift, you are expecting the rock sizes to get smaller. So you're expecting a negative relationship. And we have statistical tests that actually test that. I'm introducing to one called a Spearman rank. My tutorial here tells you how to do a Spearman rank. It tells you what a null hypothesis is, as well as giving you the web links and the necessary materials to conduct that. I will also have assigned a spreadsheet that you need to use, which has got the data. I'm just going to show you that. So you need to click into spreadsheet. This is a different data set to the one in the tutorial. So don't just think you can copy my answers from the tutorial. You've got different data here. You have to use the web tools that I've shared with you to first of all conduct the Spearman rank. You then are instructed to interpret the results. It's been very slow loading up. I do apologize for that. Here we are. You've got to use this will allow you to do the Spearman rank. This here will allow you to interpret what your result actually means. Your result will fall between -1 and +1, but you've got to know what that actually therefore means. You've got to use the critical value table, which you will find as part of this link here. And then I will know whether you've understood it or not. Okay, this is quite complex stuff, and don't be too worried if you don't totally understand it. You can go into scroll down further into the textbook, and I've got a much more detailed explanation on Spearman rank further in, which should help you. I don't know the exact page it's on, and my computer is being very slow loading up. But if you do scroll through your online textbook, your student textbook, you will find more information on Spearman rank if you're struggling with it. But this web link does give you a bit more of an insight, and you could Google, what is a Spearman rank test if you're not sure. All I'm wanting to do is for you to get a result that's either going to tell you that there is a relationship or not, and how strong it is. Okay, so good luck with your virtual field trip. We're doing a beach study today. Hopefully at some point we're actually going to get to go down to a beach and do a little bit more geography, because there's lots of other great geography opportunities that you always find at a beach.